Welcome. Welcome, everyone, to the Wharton Podcast Network here on Wharton Moneyball. I'm Eric Bradlow, professor of marketing, statistics, and data science here at the Wharton School. I'm joined today by my two longtime friends, collaborators, and co-hosts, Adi Wyner and Jensen, professors of statistics and data science. Some combination of the three of us and Cade Massey are here every week on Wharton Moneyball. Guys, I've always said from the beginning, 12 years and counting now, or right around 12 years, that the best part of our show is we get to interview people that are doing what we do for a living, but actually in the real world, if you'd like. I mean, we have day jobs, and our next guest, Micah McCurdy, longtime recurring guest here on Wharton Moneyball. Everybody knows him. He's a mathematician. We were just discussing off air what he teaches, what you would expect a mathematician at a university to teach. He was educated in Canada, England, and Australia. He returned to his home of Canada to raise a family, teach math, and of course, the most important part of his life, to help us better understand hockey. He runs and I don't know why he put this word in his own description, the moderately popular, we think it's very popular, hockey visualization site, HockeyViz. He lives in Halifax, Nova Scotia with his wife and two children. Micah, welcome back to Wharton Moneyball.
Thanks for having me.
Well, it's great to have you back. And, this is an exciting time for hockey. It really is. It's a big part of the season. Let me just start with the basics. Let's start with HockeyViz, which you could imagine Viz might stand for visualization. And I know a lot of the work you do is visual. For our listeners that haven't heard you on the show before, what made you think about not only doing, it's called the analytics of hockey, but representing it in a multi-dimensional visual way?
So the really short origin story is that I was real homesick for Canada doing my PhD in Australia, and I missed having hockey around. And I was a pretty casual fan in Canada, but then in Australia I found because I missed it, I reached out to it and got a lot more interested in it and wanted to do some little simulations to figure out how likely the Senators were to take 2, 4, 6, somewhere in between points from a California road trip. And so I thought, well, I'll have to simulate that, and the teams aren't the same strength. And then it kind of all got out of hand. That was 15 years ago now, and it was just a hobby for myself, just for friends, just a little curiosity. But the visualization part came about not because of any real deliberate strategy, except the fact that I, despite stereotypes, am not particularly fond of numbers. In particular, I don't understand information by reading numbers. And so some of the academic training that I had from some of my previous stuff was all strongly emphasizing just graphing data all the time. Just if you think you understand what you're doing, just make a graph. And that you can use your visual intuition about two-dimensional space together with your symbolic intuition, with your other knowledges. And so at first it was just a debugging tool. I just didn't understand anything until I saw it in a picture. And then I started sharing it first on Twitter, now on Blue Sky. In fact, first on Facebook forever ago, and then on Twitter, and then on Blue Sky. And gradually people started to say, oh, can you look into this for me? Can you look into that for me? And so what started as purely descriptive statistics so that I could understand my own simulations, just sort of slowly snowballed. But it's not a sort of deliberate, like I'm going to sit down and make a business. That part came afterwards, to my great surprise. Although my wife doesn't like it when I say that out loud. She says, I always knew it was going to work, and I shouldn't be so self-deprecating. So there you go.
Let me ask you a question. A lot of our listeners here on Wharton Moneyball might say, wait a second, I thought you said that Micah's a mathematician. What's he doing all this simulation stuff for? So could you tell us, how much of what you do, and look, I'm only looking at Adi. I'm looking at, for our listeners here, Adi is trained as not only a statistician, but a probabilist, spent maybe the first half of his career, I'll call it proving things, deriving things, etc. And now we live in a world of simulation, which can allow us to model richer things, but maybe not in a more as general a way in some ways. How do you think of the role of simulation in your work versus mathematics in your work?
Well, so I made a serious career change away from science into mathematics, into pure mathematics. In fact, my PhD is in extremely pure mathematics. And while I love it still, it does not engender itself to steady employment, even more so than all the other kinds of mathematics. And moreover, I found, in addition to that homesickness, I found that I was also kind of jonesing for that computational aspect. In some of my high school work for myself, and in some university work too, I did some physics papers I wrote with a man named Andrew Rutenberg, who's still a mentor to me. We're singing a choir now together, and he's a simulationist, and that's his primary work. And he taught me a lot about simulation physics. And so it's funny, I left physics behind, so I thought, at the age of 22, only to recover it 10, now 20 years later. And part of it was the sort of fun of just saying, well, here's a little gadget. What happens when it has a kind of a crafty aspect to it. You don't have to convince me about the joy of figuring something out from first principles and then convincing somebody else of it, just on a sheet of paper or just on a whiteboard, like that kind of thing. That's really satisfying. But it doesn't have that kind of like, oh, here's a little thing. What does it do? And so simulation was part of why I chose that project as like a fun project. And then from there, it just gets more and more powerful. Once you have measurements for players that are half decent, now all of a sudden your simulations are a lot more interesting than just here's a fun little toy. And because it grows naturally like that, from a little toy into something serious, which you don't get so much with a kind of like, I'm going to sit down and give you a treatment of some subject from, the bare metal. That if you can do that, then so much the better. But you can kind of bootstrap your way into something interesting with simulation work. And that's with no pun intended on bootstrap.
Bootstrap. That pun. This is the right show. That was a good pun.
You can cut that, I guess.
Hold on a second. Wait. I got to lead in for you. Adi, you're next, but I got to make a lead in. I'm sitting here knowing Adi for 25 years. I have no idea whether he's going to ask you about math, simulation, or your singing right now. It could be any of the three of them, given who he is. But Adi Wyner, please.
Yeah, I'm going to pass on the singing, although I'd love to talk about that offline. But I'm actually, I'm preparing for my course next week, which is on sports analytics. It's to our NBAs. And so I want to teach them, if they had more math, I would show them how to do empirical Bayes, conjugate priors, and forecast, say, next year's or the second half of the season's batting averages or whatever it is that you're doing with sports analytics in the classic mathematical framework. But I can't do that because I don't have that time and they don't have that knowledge. So I've discovered that I could teach this purely with simulation and essentially first principles. It's remarkable. You can use split samples and use you have to do a little bit of math just because you can't get away from it 100%. But it's incredible what you can do, and there's a whole school of statistics teaching, and which is really apropos to sports, where you essentially dispense with the asymptotics and all the glorious work that has made statistics possible for so long because we didn't have computers, and replace it with things like bootstrap, permutation tests, split samples to get prediction intervals and confidence ranges and bootstrapping. And it's remarkable. And I wonder whether or not all that theory, which was wonderful for us to get us to where we are, will eventually just be just one of the bag's tools in the bag and not the main event.
So it's funny you should put it that way, because I have been trying to persuade my university to let me offer a course a little bit like that, targeted not at MBA folks, but instead at people who want like a funny quirk on a math degree. Mm-hmm. Would you like some sort of data sciencey kind of angle? Would you like some sort of? But I despite being a mathematician, pure by training and applied by work, I'm not a statistician, mm-hmm. and I've made a lot of friends with a lot of statisticians, but every now and again when they talk real turkey, I have to say, sorry, you have to prove this to me. I don't understand. I don't know what you're talking about. And so I'm in this sort of peculiar situation of knowing a lot of stats, but not actually knowing any stats in a way.
Well, so I'm going to give Shane the next question, but this will be the last generic question because I want to talk to Micah about this year's hockey. But he's so interesting just in the way you're thinking about solving stuff. But please, Shane, go ahead. And of course, it is pride of Canada here.
It is another generic observation, kind of more maybe feeding off of what Adi said about how we're doing more kind of simulation-based teaching and less of teaching maybe the asymptotics. I kind of feel like even when I was teaching in intro courses, the asymptotics, I was teaching it kind of via simulation as a thought experiment. Like I feel like when you think about the sampling distribution of the mean or something like that, you're automatically kind of doing a thought experiment simulation in your head anyway. I kind of feel like it's maybe like, maybe they're kind of more deeply linked even than that. But regardless, that was just kind of the observation. And I feel like I have maybe my background or whatever. I always essentially taught asymptotics via simulation anyway.
Sports really encourages that.
Yep.
Yeah.
Yep. No question about it. All right. So, Micah, here's the first question. It's not on your list, but given we're in the home soon to be of champions, the Flyers. So let me ask you to think about the Flyers. No, but I have a very specific question. Okay. So you come up with a visualization that says right now maybe the Flyers have, what is it, about 60-something% to beat the Penguins? It's something like that.
Yep.
Yeah. Okay. So when you think about that, there are two factors I can imagine. One is they're up 2-0. And so what you do is you compute the probability that they would win given they're up 2-0. Okay. Another thing is that you're going to do that because they are up 2-0, but have to adjust your assessment of their underlying theta because they're up 2-0. When you think about this, how stable do you think about the strengths when you're coming up with these probabilities?
So I actually take a pretty doctrinaire approach to this kind of thing. And it may not be what people expect. In particular, the attitude that I take is that everything that you're measuring is either a person or it's geometry. And you can't, is physics, maybe even more broadly than just geometry. And so the people in particular, I understand to change really slowly. And so if you have a good bead on the ability of the players, that's a big if, but if you do, then the fact that the Flyers have won 1 game or 2 games or even 10 games weighs surprisingly little on the ability of the players. And so the simulations that I'm doing, I'm starting from, this is how good I think the people that the Flyers are going to put on the ice are, as well as this is how good I think their coaches, this is how good I think anyone else who makes a relevant decision for on-ice stuff. And so I try not to include anything about laundry, if you like, anything about the teams themselves, like as such. So
let me ask you a question. Is the whole equal to the sum of its parts? Or are there interaction effects between, how do you, let's even imagine I give you all these strengths of the players, the coach, etc. Is it a summation or is it something more complicated than that?
Well, so in my case, I have a simulation model at another level where I'm simulating the game itself. Who is going to play with who is going to actually be on the ice against whom. And so I'll just run any number of simulations of the game.
Got it.
And so it's not just that I'm simulating the remainder of the series, but then of course the shifts are also in a way being simulated so it's sort of simulation all the way down. And that if you like is just physics training, I suppose. But I find it really satisfactory to explain, at least to myself and sometimes to other people too, even though, of course, it has to be simplified in places. It's not actually the hockey game.
Yeah, I saw Shane's hand up. I just want to ask a clarifying question on this simulation, just to be clear. So let's imagine I'm even showing you my lack of knowledge. There's a goalie and 5, 6 players on the ice at once?
5 as a rule?
5, yeah, goalie and 5. If I told you the strengths of this 5 players and the strengths of this 5 players playing against each other and the strengths of the goalie, would your simulation then output a probability of scoring? Like those are the primitives, and that's when you simulate and players are going in and out, but at any point in time, there's my 6 strengths against your 6 strengths, and that's what's determining what goes on.
Yep. In fact, it's sort of 2 or 3 models, but then taken together, they do exactly that.
Ah, great. Sorry, Shane, I saw your hand up.
Yeah, no, and obviously you're modeling and simulating this at kind of at a shift by shift level. It sounds like, as opposed to kind of like a series by series level. But I when I thought about sort of simulating, say, the hockey playoffs, and I specifically have been thinking a bunch about this kind of the President's Trophy curse or whatever. The fact that we often have the top team in hockey knocked out in the first round, or that seems to happen more probably than it should. And it got me kind of thinking about Eric's frequent kind of comment on these shows, which is momentum versus, kind of bad, a simulation of hockey playoffs where the two factors are basically either the quality of the team or the momentum of the team. And I do kind of feel like hockey playoffs are uniquely designed to kind of pair up, because the top teams like Colorado, say for example, are always kind of going up against wild card teams. And could we see, so basically, is there kind of a curse to being in the top place in hockey because you get paired up against the team that is most likely going to be on like a momentum-based run going into the playoffs, just because of that kind of 1 versus 8 sort of seeding?
It doesn't seem implausible, but I have a sort of asceticism of sorts where if there is such a thing, then I don't quite consider it legitimate to include until I can model it somehow. Where does it?
But let me just tell you, it's real, all right. But sorry, go ahead.
And I don't.
I guess the way one, if it existed, I agree. If it existed, the way I think you would build in the model is, you said before that your primitives, like player ability essentially, are very slowly evolving, maybe not actually even evolving once you get to the playoff parameters. And this would be kind of like, it'd be kind of like doing some kind of more like kind of like short term, maybe for a subset team, some of those parameters are changing more rapidly. That would be kind of how I think I would build the concept of momentum or something like that.
Or Shane, what you could do
model.
is, and maybe Micah does this already, which would be, let's imagine we're sitting here at game 82 just before the playoffs start, right? We're going to take a window going backwards. Maybe that's all 82 games. Maybe it's a shorter number of games. You could fit the window size that gives you the best predictive ability historically over the data set. So another simple way to do what Shane's talking about would be to just take model abilities in some more localized window around the playoffs and call that, if you want to call it non-stationarity, I'm fine with that too, or some form of momentum.
So I don't do this right now, but I have done it in the past. In fact, I found, this is anecdotal, of course, but I found that 25 games was a useful window to look back. Not instead of, but in addition to a longer time.
Interesting.
Precisely how those got mixed is a little bit ad hoc. This is part of why I left it behind. But now I use a sort of more instantaneous, like kind of trying to get a beat on player ability that's a little bit more like the speedometer in your car. Like where it's understood that it's a continuous measurement. And then I suppose if you were going to layer on more detailed characteristics on top of that, the question is going to be, well, how? And so you could just take a window like that. But then I always sort of want to get a little bit deeper into it, into maybe it's something about coming from science rather than coming from statistics. Is that if I can't get a hold of something where I can say, look, this is what people are like, specifically these interesting people, with their extremely fancy jobs and where they play hockey for our amusement, that aspect of personality, even if I have to get at it very clumsily, I would still rather try and fail than just say, well, let's just throw some big number on it.
Mm-hmm. I like it. Yeah, Adi, please.
All right, so I got 2 questions. I'll start with this one because it's been burning on my mind based on a competition that we just did with high school students with a simulated hockey season. Shane was part of this as well. And it has to do with the goalie. So we built a model where the goalie effect was actually quite large. It was simulated hockey, not real hockey. And part of the reason we did that is that based on real data, if I told you, for example, that the 2 factors about a team, one was the goalie's historical G over XG, in other words, how many goals did he give up versus how many shots would you expected, versus your opponent's, the XG differential for the 2 teams. So like the quantity of quality shots they're been making, they both were kind of equal in terms of their predictive quality. I thought that the goalie would get trounced by the quality and number of shots that each side was taking, but it turned out the goalie's really, really important in describing what happens in the past. And I'm really not sure whether that really describes what happens so much in the future, or so in other words, goalie performance, we've talked about that on our show, is very important in figuring out who wins a match, but I'm not so sure how important it is in predicting who will win matches. And so what we hear is goalie actually matters a lot, and goalies can get hot. Or is that hot because it's non-stationary, or is it hot because it's just psychology? It's not really hot; it just looks like good work. Or is it or is it genuine psychological heat of the classic momentum definition? So I'd love to hear your opinions. And once you do that one, I have a second question. So I want to cue that up.
I on the one hand, I strongly suspect that there is something just latent, just that we're not catching, that I don't have data for, or that I'm not perceiving correctly. A really classic hidden variable kind of, it looks blurry to you because you're just not resolving the things that you should be resolving. There are features here, how much time does that guy have to take that shot? How much time does that goalie have to actually make a read? That kind of stuff, like how occluded, how good is that screen? All kinds of stuff like that we're just, that we're getting really, I'm getting really clumsy proxies on, if anything. And so, but on the other hand, it seems tempting to me to imagine that you could have some kind of literally psychological treatment there, where especially part of why it's on my mind actually is because Linus Ullmark, the goaltender for the Ottawa Senators, took a leave of absence to deal with anxiety problems in the middle of this regular season. And then was extraordinary last night. And it's not just, it's not just unusual for a male athlete to do such a thing in the middle of a pro season, but it's also striking because you could see him playing badly before it. And then he took a goodish chunk of time off. I don't know exactly what kind of care he got, but it seems to have been reasonably good. And now he came back and he's been much, much stronger. And so that, anecdotal, I suppose, but it points to a reasonably plain psychological explanation for on-ice results. The mechanism of which I think is going to be really tricky to model.
Mm-hmm. Adi, you had a second question?
So my second question is, so when I love to be what I would call smart, stupid modelers. So what does that mean? Take a sport that I don't know much about, that makes me stupid, and then model it in what I would call decently smart techniques. I've done this with like football, for example, and I've demonstrated pretty convincingly that while I can't beat the smart modelers, I can get pretty close in terms of forecasting probabilities of outcomes with very, very simple stuff. So in hockey, my question is, if I were to just model teams based on score differentials, a schedule adjusted score differential type thing. So that's what I mean by smart, stupid.
Sure.
How would I do in terms of predicting outcomes of these playoff games as opposed to someone who did fancy simulations and was smart? What fraction of the data of the signal do I get by being smart, stupid?
A lot.
Okay.
I don't know. It's sort of not precisely well posed as a question, but something like 80-85%.
Mm-hmm.
Like you could. It's funny, the phrase that you use, the smart stupid, I call physicist thinking, just because of there's this really kind of uncomfortable habit of physicists to sort of wander into any discipline and just say, have you considered approximating this with a tangent plane and sort of swanning out after doing nothing useful whatsoever. But really basic simulation principles and a head on your shoulders can take you a very long way. Like I noticed, for instance, I run a prediction contest for the regular season every year, where I give whoever wins a lot of sour candy. That's for historical interest. But one of the things that you can really tell is that some people are just winging it. They're just putting in whatever numbers based on, whatever they feel like. And other people are actually doing simple things like making sure that the number of points adds up to a number of points that is possible for the whole season, or possibly going further than that and actually like simulating something. Who knows? And you see a really, really big difference. And then after that, so as long as you do something sensible, you can get sort of to the same place that all of the other people doing something sensible get to. And then the real struggle comes from, now what do you do? What are you going to try to actually get some juice out of something? And there you find almost immediately, well, let's try this. It doesn't help. Let's try that. It doesn't help. You can, like I would say, if you went one step further than what you said and actually used both goaltenders and finishers, so just measured with goals per expected, And then also something about chances, pure chances without finishing ability. Like if you separated out those two features into two separate things, you would already have something like 95% of what
So
you could.
I think the other nice
Wait.
thing about, I want to move on to one other question, Adi, but I think the other nice thing about simulation, of course, is you can answer a lot of other questions along the way that aren't necessarily, that's a thing, is that once you have, as Shane mentioned earlier, the shift level, once you have a full simulation, all kinds of things you could answer. And in some sense, it's consistent and coherent because it's coming from the same underlying primitives.
In fact, if you like, one of my favorite examples of this is that during one of the worst parts of COVID, when everybody was stuck in their bedrooms, I dug out the simulator and just loaded up the 1819 Detroit Red Wings and I forget precisely which year, the darkest depths of the tank Buffalo Sabres, and the two worst teams I think we've seen in the last 2 decades, and imagined a 7-game series between them. And I just got the simulation to sort of just tell me its debugging output, and I just turned it into a story, and people loved it. It was just a hoot. There wasn't any real point to it. But once you have a simulation model, you can play games with it. You don't even have to do real work with it.
So let me ask you a couple questions from your list in the last few minutes that we have. So one of the things you wrote down is isolating individual player and referee impacts on minor penalties drawn and taken. So without knowing what you're going to do, I'm going to go back to my ETS days and say how I would answer the question. Okay. And then you'll tell me whether what I'm saying is totally stupid. Let's imagine a table where the rows are the referees and the columns are the players. Okay. And so we have entries when certain referees are calling penalties on certain players, right? In the educational testing world, one could be examinees, the other being test items. And we estimate row and column effects. So some players are more likely to get penalties than others. Some referees are more likely to give penalties than others. And this, depending on what model we fit, we can decompose the two of those things. So is what you're doing anything like that, or am I totally off base what you're thinking about or doing?
Surprisingly similar in the end. It slightly more sophisticated in terms of structure, where I can like nest things inside one another. But broadly, yeah, that's the approach. Does your presence on the ice cause your team to take penalties, or the opposite, or neither? And I didn't get as far as actually putting individual referee names on stuff. I've been yelled at before about doing stuff like that, so back channels. But I may well be able to get a hold of something like that. I'm actually just about to release a little write-up, but a paper, I guess I would call it, if I was going to publish it. But I think I managed to isolate that referees are driving some of the effects that we see. That it's not can't be exclusively attributed to.
Okay. So, Michael, let me ask you another question. One of the another topics on here was age curves. And I love the way it's phrased, solving age curves alongside teammate and competition effects. Like, am I old, or the people next to me suck, or I just happen to be playing against really good people? How do we figure all that out?
Well, so this is something that I have gotten some progress on, but so far, until very recently, the aging work and the sort of specific ability work has been separate. So I have like a model for who's a good finisher, a model for who's a good shot generator, a model for who's a good shot suppressor, all these other, specific hockey skills. And then I can go and take those measurements afterwards and say, okay, now let's figure out an aging curve for those things. But of course, it doesn't take too long of doing that, in my case, a year or two, before you realize you really want to do those things at the same time. Because among other things, you get into what I call the moving elevators problem, where if you take an older, strong player who's declining because they're older, and then pair them with a younger player who's improving. Sometimes you do this, sometimes, you have to worry about bias all the time. Sometimes these things happen accidentally, or it's just sort of along the way. But other times they happen on purpose. We like that as a coaching choice. We're going to put this guy, his legs are no good anymore. So we're going to play him with a young guy whose legs are amazing.
Right.
Also, this young player who's with amazing legs is actually a superstar in the making. So we hope, and we would like him to get better. We'd like, the specific example that I had in my mind from last year was Claude Giroux, Flyers legend, now in his older age for a hockey player in Ottawa, with being routinely paired with Tim Stützle, and worrying that I wasn't getting the credit apportioned right, because you have two players who are staple to one another, and that's already a problem, except in sort of generalities that the aging curves are taking them in the opposite direction. So if you take something naive where you're not including the aging, the measurements that you're going to get themselves are going to be slightly wrong for that reason. And so I think at last I have figured out a way that I can start to integrate the aging curve measurements into the model measurements. And so we'll see if that works. Maybe you can have me back on in a month or two. But I considered this to be a huge pain in the neck until sort of all of a sudden I have a model idea for a regression technique that might be able to solve it with the computers I currently have.
So maybe just in the last minute we have, so how do you see the Stanley Cup playoffs playing out? Like, how, do you have well, let's wait, a couple things. One is, according to your sims, there has to be a predicted winner by the definition of a sim. Like, it will give you a predicted winner of the playoffs.
Yep.
Both, who is that and how certain are we? Like, I'll ask you in two ways. What's the probability of whatever team that is actually winning? Like, how much higher is it than, if I've got this right, there are 16 teams in the playoffs right now. Yep. And so how much higher than 1/16 is it? And then number two, how many teams would I have to take? We always like to ask this question so that it would be even money. Like, I give you 3 teams and I get 13. Is that an even money bet? Or you have 5 and I have 11? So I'm just wondering, what's the distribution of win percentages? So how do you view both? What do you see for both of those things?
So first of all, the short answer is Colorado. They're the best team in the league this year. Their probability as of right now, and they're up 1-0 in their series, their probability is about 37% to win the cup.
Wow.
That is unusually high for a single team. Most years, so to answer your second question, most years, if you wanted to make an even money field, it would be 5 versus 11 would be typical. Sometimes 6, sometimes 4. This year it's 2. And the second team is Carolina, 20% as of the moment. And so then 20 plus 37, you're already over 50. Wow. And they were both over 50 or very, very close, even before the playoffs started. Carolina, of course, is up 2-0 on Ottawa in the first round. But that is unusual. This year specifically, there are very few bad teams and a lot of middling teams, some of which made the playoffs, and only a couple good teams. And so they look really good by comparison to the very average field.
Well, Micah, that's fascinating. Shane, before we let Micah go, any reaction to 37-20? Does that seem like, oh my God?
It sounds high, but I mean, when you were first starting to talk about Colorado, I was thinking to myself, oh, well, what about Carolina? I was thinking, oh, maybe Carolina should actually have the higher percentage because it's maybe got the easier path. But the fact that it's basically the second highest anyway, maybe if you could talk a little, just very briefly, like the 37%. Like you've got kind of Colorado almost twice as much as the next high, like Carolina. Kind of, those are two relatively independent trajectories, at least the two of those that have.
Mostly.
Do you is it kind of in the primitives? Is Colorado really that much better?
Yes, and that's part of why I don't feel bad of saying so, even though for 6, 7, 8 years in a row, I would have said, oh, that's a mistake, 37%. That's far too high for a single team. But this year, I feel a lot happier about it because I've been watching the primitives, if you like, about, Nathan McKinnon, Cale Makar, the Wedgwood having a tremendous year, a lot of just really high quality skaters.
Maybe a corollary to Shane's question. No, then we're going to let you go. If Carolina were to play Colorado, I guess that would be in the Stanley Cup Finals, right? It would have to be. Yeah. What would Colorado's win probability? How much of that 37-20 is coming from a head-to-head matchup if they just get there? Or how much of it is Shane's intuition that a lot of it could be the path to get there?
So the path is easy for Carolina. That's part of.
So it would be even greater. So you're saying then if the path is easier, then it's got to be even more extreme than 37-20 in the finals.
It is. Yeah, it is. It's more like 65, 62 maybe. I looked it up the other day and I don't have it right in front of me, but it's in that territory. It's hefty.
Wow.
Yeah, and Carolina are no slouches. They're extremely good.
Huh. Yeah. Well, Micah, as always, it's great to have you here on Wharton Moneyball. We've been joined by Micah McCurdy. As he told me before the show started, 100% time mathematician, 100% time father and husband, 100% of the time the creator of HockeyViz. Micah, thank you again for joining us here on Wharton Moneyball.
Thank you all very much.
So please stay with us and join us right after the break. Welcome back. Welcome back to Wharton Moneyball here on the Wharton Podcast Network. Eric Bradlow, professor of marketing, statistics, and data science here at the Wharton School. I'm joined by my two longtime friends and collaborators, Jensen and Adi Wyner, both professors of statistics and data science. And again, some combination of us and Cade Massey are here every week on Wharton Moneyball. Guys, I just want to say, I'll tell you why I felt so good about that interview we just did with Micah McCurdy. First, he's great, and I think his insights are tremendous. But secondly, more so for Adi and myself. I mean, Shane, I expect you to ask intelligent questions about hockey, but I don't think Adi and my questions were totally moronic. I think we may have actually learned something over 12 years. What the hell?
No, yeah. The only thing moronic was that expectation that I would only ask intelligent questions. But yeah. No. That was
either way. We're all doing fine.
Yeah.
We're doing fine.
Yeah,
so, guys, as you know, in the second half of the show, we typically do what caught our eye in sports. Adi, I'll start with you. There's lots to talk about: baseball, NBA,
plenty to talk about.
Any NFL draft coming up, whatever you want to talk about. What caught your eye?
There's a lot. I mean, so as you guys all know, our listeners know, you guys know, I try to catch most Yankee games. I actually went to a Yankee game. I went to a Phillies game. So 2 games since we last got together. It's always nice to go to a baseball game. So I'll just point out one thing general, one thing specific about baseball. First of all, the American League is getting its ass handed to them by the National League. Only 4 teams in the American League have a winning record. As of before last night's game.
The American League teams played the National League teams?
Yeah, they play each other. Sure, a lot.
Interleague play, you mean specifically?
No. Just in general, their records. So it has to. I mean, you'd think that there should be some more or less balance if they're only playing each other, but they're not. They do play a lot of interleague. So there are 9 teams in the National League with winning records, and only 4 in the American League. That was prior to last night's games. I didn't update what happened last night. And I'm thinking, because like the Yankees have the best record in the AL, and it's crap. I mean, and there's only like a couple other teams who are like hanging in there, and in the National League, like whole divisions are above 500. So just an observation, it definitely caught my eye, and I'm kind of wondering whether this is just the vagaries of small samples, or is it really?
Like last year, I feel like around this time, or maybe preseason last year, we went in saying like, oh, well, the top, like there might be 1 or 2 AL teams that are in the top 8 teams going in. So I kind of feel like this is maybe, I mean, maybe it's not the same teams or whatever, but no, I kind of feel like this is a lot of the kind of elite player movement, at least, that we've seen.
It's gone to the NL. Well, the Dodgers have been sucking them up.
And the Mets.
Shane,
the Mets.
If you look at, just to build on that, if you look at fan graphs, let's just go through it quickly. Top 8. This is projected wins by the end of the season. Last time I checked, Dodgers, National League, right? Braves, National League. Yankees, American League. Last time I checked, Pirates, National League. Cubs, National League. Tigers, American League. Mariners, I think, are still in the American League. Padres, National League. Phillies, National League. Brewers, National League. So I've just named the top 10.
Did you say Pirates? At
Pirates?
4?
But
Pirates are really good this year. They're shocking.
Yeah, the Pirates are predicted 85 total wins. I mean, it's a 4-way tie for 4th, but whatever. The Pirates are projected 85 total wins right now on Fangraphs, which is 4th highest projection right now.
Huh.
Yeah, I did. I said the Pirates.
All right. I mean,
I know
certainly
the Bucks fans in Pittsburgh are like quaking. This can't be right. They're like,
but
there's got to be something wrong with the math.
Whether you want to take the top 10, where it's 7-3, or the top 5, it's 4-1. The Yankees are the lone team sitting there amongst the Dodgers, Braves, Pirates, and Cubs. And so, we're not even counting some other teams that are off to some really good starts.
Well, I mean, that's the thing is, in part, that's Fangraphs. Fangraphs sounds like it's weighting tremendously towards in-season so far versus preseason expectations. If you had any kind of
Fangraphs is pretty slow learner.
What was the Pirates preseason? Were they in the top 10?
Shane, it's just a little over 500 because right now the Pirates are playing roughly 600 ball. but Fangraphs only has them going 520 the rest of the season, like 72 and 68. But you add that to the 13 wins they have now.
Well, you know,
they get to
I mean,
85.
I'm just saying
to be fair, the
Blue
Pirates are really building. They have tremendous young talent. Paul Skeens at the top. But still only 520. We're not expecting them to be that good.
All right, let's go back to you. I forget if that was your specific or
no,
general
so that was my
comment.
first observation. The second observation, I'm going to bring this up every week until I get an answer. We can actually discuss this. We talked about it a little bit last week. What do you do with Trent Grisham? The Trent Grisham problem. I talk about this constantly. He did manage to hit a home run the other night. Here's a guy who I looked at his record carefully. 6 years of complete lower than mediocrity, barely getting a win over replacement. Last year he had a couple. He was pretty good. And the Yankees gave him a $20 million contract. I thought that's just insane. And of course, coming out of the gate this year,
is the problem that the Yankees actually have mediocre players at some positions?
No, they just, to me, it's that they would fall for.
What's the problem here?
To me, that a serious analytics staff shouldn't fall for recency bias. And the way they appear to me to have fallen pretty hard for recency bias. And your model should take care of that. So maybe I haven't done the real gritty work yet, but and maybe they're not looking at just performance data. A lot of things that the actual teams are looking at is this peripheral information that we don't get. We could get, or we don't generally dig into the hard hit rate, the pull rates, the expectations of how you'll do in Yankee Stadium compared to he was playing in San Diego before. That's a crap park. And he pulls the ball, and they clearly hit more home runs last year. But maybe they're seeing something that I'm not. But I'm just as again, let's be what I called before smart stupid. So I'm not going to take all the fancy information that the high tech people will use. That's the stupid part. But I'm going to use the information that I do have smartly. And it just doesn't seem to me that was a good move. And so that's and I'll just keep my Trent Grisham watch going for the rest of the season. Obviously, as a Yankee fan, I hope he cleans up and does fantastic. But as a statistician, I'm thinking not a good move.
All
that's
right.
my take.
Spain, what caught your eye in sports? Maybe it's around hockey, or it could be around any sport.
Yeah, I'll talk baseball as well. But first of all, I just want to say, Adi, I'm glad you've got somebody else to kvetch about. Is that the right way to say it?
Kvetch. You got to say your Yiddish properly. Kvetch.
Yeah, kvetch about besides Anthony Volpe. It sounds like you found a second target there.
Yeah, definitely.
But yeah, I guess I'll do another baseball one because we are kind of, I think, still in sort of the silly kind of like overly interpreting small sample kind of part of the season. The one that kind of stood out to me is Mason Miller, the closer for the Padres, has faced 38 batters this season and struck out 27 of them.
He's actually slumping, Shane. I looked at his stats like 4 days ago, and he had struck out 23 of 29. He's only struck out 4 of his last 9, Shane. It's not looking good.
That K rate coming down from like 15 or whatever the heck it is right now. It's just like...
By the way, last time I checked, Shane, I don't know if this is true. When I looked, he had struck out 23 and walked 0.
Yeah, I mean, his whip is like 0.3 or something.
No, but I'm saying
like
he had
that.
struck out 23 of 29 and walked 0.
So I mean, obviously, we're all, our reactions all say there's no way. I mean, this is not sustainable.
No,
and I guess it kind of leads me like I'd love to hear from you guys. What do you think the best sustainable relief, like what the sustainable version of like this is like what if you had to
40%
guess what
strikeout rate. That's
and like
unbelievable.
a whip more like point, like his whip's going to be double that by the end of the season.
Yeah.
Right?
Oh, yeah. But no.
Doesn't take very many walks.
Shane's bringing up 3 interesting points. One interesting point with 3 prongs to it. One is there's 3 things that are amazing by what he's doing. His strikeout rate, his ERA, which is, of course, 0, and his whip. Which of these 3 do we think will be the most outlying or in a multi-dimensional space, which of these will be most outlined by the end of the season? And is the combination of these 3 going to be even more outlying? Like he'll be at the 99th percentile of strikeout rate, maybe ERA and whip, which in a 3-dimensional space will make it even more impressive what he's doing. That's what I'm hearing.
Are you talking Manalobas distance? Yes,
I am.
Probably. Yeah, collectively. I mean, listen, there's been absurdly good seasons by relievers over historically. ERAs around or even less than 1, ridiculous strikeout rates. I think he's in line to be one of those. Will he compete? Will he continue what he's done so far? No, that's immortal.
Yeah.
It'll regress down, but is a long way to regress down and still be in the greatness area.
Yeah, and I guess like I'm using him as a way of thinking about like what is the reasonable like lower bound on ERA
Yeah, right.
for a full season and whip, and it's like got to be at least double what he's doing right now on the
Yep.
whip front at least.
So I'm going to stay with baseball with what caught my eye. I've been texting you guys about this. So as if we didn't have to talk about another great thing of Shohei Ohtani. So he actually is currently on a 52-game on-base streak. Now, that, of course, includes walks, hit by pitches, other stuff. Now, just to remind everybody knows, Joe DiMaggio's streak is a hit streak. That's 56. The all-time on-base streak is Ted Williams, 84. Okay. The next highest after that, I think, is like in the low 70s. So Ted Williams is very outlying. But Shohei's 52 is the 28th longest all time, but it is the longest since A-Rod in 2004. So, and the longest Dodger one ever is 58 games, and I think it was Gil Hodges or somebody like that. But, like, it's getting to the point where, he's setting records at a very fast pace. And the other thing I did, which was fun for ChatGPT, I actually like ChatGPT's answer here. I said, which one's more impressive, Ted Williams' 84-game streak or DiMaggio's 56-game streak? And it did a bunch of calculations. First of all, I liked that it reflected some uncertainty. It said, well, you'd have to make lots of assumptions, et cetera, et cetera, et cetera. But it basically said there's no comparison. It's what Adi said also on the text chain. It said, conservatively, DiMaggio's streak is probably 100 times as rare. And non-conservatively, it might be 1,000 times, or maybe the odd one's conservative. It's not even close, it's orders of magnitude more rare, 56 hits than 84 on base, which was a consistent, Adi, with yours. Like you answered in 10 seconds or 2 seconds, not close.
Well, I actually do that calculation in Moneyball Academy with my students in the full Moneyball Academy, the full 3-week program. And basically, DiMaggio had 3 things going for him that made it even remotely possible. Obviously, a very high batting average. So when he did put the ball in play, he did. It was
357 that season.
That season, and during the streak, it was around not even that much higher, closer to 400 during the streak. He also almost never walked, which is generally a bad thing for baseball players, but a great thing for hitting streaks. You really need that low walk rate in order to get the at-bats to generate these hit streaks. And frankly, nobody does that. No modern player today doesn't walk. In fact, DiMaggio was asked in some level, why don't you walk? And it really reflects the changing understanding of the game. He said, the fans don't come to see me to walk. Which is an interesting question. It's almost like softball when you're playing pickup softball. Nobody wants to walk. You want to get to hit the ball.
You could also
that's
make
not
an
Major
argument,
League Baseball.
Ted Williams had the most famous vision of any player. Ted Williams walked a ton.
Yeah.
Well, it's funny because he also had the completely opposite attitude towards the fans. DiMaggio said, they're coming to see me. I need to be as good as I can possibly be every single time. And it's quite of his part of his personality. Why does he play so hard? And he said, he would say, because someone might be here to see me for the very first time. And Ted Williams, his attitude was, I don't give a crap. He was so notoriously anti the fans. And I mean, so much so, if you've read a biography of Williams, it's fascinating. But Ted Williams would say repeatedly, I'm here to hit, and I can't hit a ball that's out of the strike zone, and no way I'm swinging at it. And even more tellingly, I can't hit a pitch that might even be in the strike zone. It's just in a place I can't do anything with. And that's a testimony to his brilliance as a hitter, which really was, I think, probably unsurpassed by anyone. I hate to admit this, but yes. But so DiMaggio had those 3 things together: the high at bat. Oh, I didn't say the third one. The third one, which is actually also very important. He almost never struck out. So he didn't strike out. He didn't walk. And when he did put the ball in play, he hit it hard. So many opportunities to get hits, whether those were picking up infield hits because he didn't strike out, whether by not walking, he would typically have 5, sometimes 6 at bats in a game. And Williams would have 3. It was very common, right? So you can't have hitting streaks if you're only batting 3 times a game. And finally, of course, he hit the ball so damn hard and getting and on the line, so he got a lot of hits that way. So when you talk about the probability of 56, it's 100 times greater, and that's for Shohei. You're just not going to see 56. Just never going to happen.
Yeah, they said it was something of 250 years.
It's done. It's done.
No,
nobody hits that way anymore.
They said Ted Williams could be broken. Maybe it's 25 years, 30 years, 40 years.
Yeah.
But I mean, I know people say, wow, 40 years, 250. Oh, no, it's a big difference between 40 years and 250 years.
The only one who had a chance to beat DiMaggio was Ichiro. Yeah. Same style.
Right. All right, Adi, you're next. Let's go round 2. Anything else caught your eye in sports this week?
Anything caught my eye in sports. So I haven't really been paying attention much to the playoffs. I was looking a little bit at the NBA playoff sort of lineup, and in preparation for the class. In previous 2 seasons, there was an extremeness about the Celtics 2 years ago when they won, insofar as that they were not only the favorite, during the regular season, they significantly underperformed in terms of wins, their expected wins using a Pythagorean type identity. In other words, they did great, but we expected them to do even better, and they won. Last year, of course, there was they were just saying, I guess, who won last year?
Jason Tatum went down with an ACL, with a Achilles injury.
And it was totally different. But last year, it was almost as expected. It was tight, that there were 3 teams that all were extraordinary in terms of their differential. This year, again, all 3 top super teams are none of them over or underperformed during their season. So I think it's going to be. I think it's pretty lopsided. It's surprising. The real good question is, would you take the field this year versus the number one?
Yeah, I mean, in our previous hockey discussion with Micah, we were talking about how many teams would you have to take to cover 50% of the chance of winning the Stanley Cup, and it was like 2 in this year, but usually 3, 4, something like that. It sounds like the last couple of years in the NBA, if you give me 3 teams, I can cover 100% of the probability of winning it all.
Getting close to it. So yeah, this year, I think OKC is responsible for over half easily.
It's not half yet. Betting odds, they're plus 150, but. And so it would take the second team, which is the Celtics, by the way, which are like at plus 500 or 550. It would take the 2 of them to get over 50%. But, and I think it would be hard for me to argue. No, what's interesting to me, actually, glad Shane brought up Micah, because I think everybody here would agree, in totality, the stronger teams are in the West. San Antonio's in the West. They had a winning record against OKC this year. Denver's in the West. They had a winning record against OKC this year. They're all in the West. But still, OKC is plus 150 and Boston's 550. It was the same question Shane asked Micah. How the hell is Colorado, 62-38 or whatever it is over Carolina, when Colorado in some sense has the harder path? Well, yeah. OKC has the harder path, and they're still a 3-1 favorite.
It's crazy how that distribution is so skewed in the NBA right now. It seems like. I mean, I know in general that happens in the NBA. It's a very dynastic.
Well, there's so many teams competing for the bottom.
Yes,
it just takes like a third of them right out. It's nuts.
Yeah.
Yep.
Yeah, that's right.
So Shane, anything else caught your eye?
Well, I'll just kind of throw one shout out to Jose Ramirez. This is a baseball one that I noticed. Jose Ramirez recently became the Cleveland Guardians' all-time leader in games played. So he is the player that has played the most games for the Cleveland Guardians / Indians franchise.
That's
in
remarkable.
That franchise's history. Yeah, and actually the list of kind of the list of most kind of most all-time leaders for across the different franchises is a fascinating one. It gives me the opportunity to also we can celebrate. Garrett Anderson is actually the Angels' all-time leader in terms of games played. He just passed away this week, shockingly. Do you guys know who it is for the Yankees without looking it up?
The most games ever in Yankee history?
Yeah, the Yankee that's played the most games for the Yankees.
It's not Derek Jeter?
It is Derek Jeter. It is.
There
I
you
guess
go.
you did know. There you go.
Well, I mean, I'm
Yeah.
just saying, you think Lou Gehrig, but he played every game, but for 16 years, not
Yeah.
basically 20 years. Mickey Mantle played 17 or 18 seasons. DiMaggio
Injured a
played
lot.
much less.
He only
and-
played 13.
Yeah, DiMaggio only played 13.
Well, he missed like 5 for the Wars.
Right. And so those are the long time. And then there's a bunch of pitchers, but pitchers don't play every day.
Yeah. So I mean, all basically looking at just kind of the top 5 across base of kind of franchise leaders in terms of games played. It's all position players. I don't think they're
Yeah.
By the Red, just in case people are interested, the Red Sox, the Yastrzemski played 3,308 games to the Red Sox. That's top all time. And then Hank Aaron for the Braves is next, and then Stan Musial for the Cardinals. And Cal
Wait,
Ripken Jr. for the
Yastrzemski's
Orioles.
ahead of Aaron? That's
Yes.
a surprise. Wow.
Well, yes, that's right.
Yeah. All right, guys. So just the last thing in the last minute or two. I can't believe the following. Well, if you know the answer to this, so Adi, I'll ask you. In basketball, okay?
I don't know the answer then.
Okay. Okay. So let me just say, you obviously know every year they announce a defensive player of the year, right?
I do. I couldn't name one, but no, that's
Okay,
not
all
true.
There's only been one in the history of basketball who's been the unanimous defensive player of the year as voted on.
Not surprised, actually.
Very surprised. And it was
You're
just
surprised by that.
yesterday,
I wouldn't be, because I think
Wembanyama.
this year it's Wembanyama.
I can't
Well,
believe
he's a freak.
you're telling me. I'll
Yeah.
make it up. Michael Jordan, Wilt Chamberlain, whoever it is, there's never been another unanimous defensive player of the year?
Well, but those players were primarily known for their offense, right?
Yeah, but
I mean, has
don't
there
know.
ever been anyone?
Well, yeah,
So,
I mean,
I
I
mean-
guess I guess what we're saying is defensive talent somehow doesn't sort of stand out. Like, you'd have to look at the distribution of these quote unquote. We're talking kind of a defensive MVP, right? So it's like what the distribution of those votes looks like.
Yeah, I'm just surprised that there isn't, even if it's just a herding mentality, that there hasn't been a herd of votes that has gone towards one player. Like, whether it's, I don't know, Dikembe Mutombo, who was like the 5-time defensive player of the year, was never the unanimous defensive MVP. Or, I don't know, Scottie
Yao Ming? Was Yao Ming
Dennis
really
Rodman.
good at defense? Yeah,
What?
yeah. Yao Ming. I don't know if he was.
Yao
on the-
Ming, Dennis Rodman.
Yeah.
Never defensive, never unanimous defense. Either way, that just caught my eye. One last thing I'll end with, guys. So Alcaraz, I love talking tennis, is injured. So has a wrist injury. He had to pull out of 2 tournaments now. He's saying he may not play the French. Now, if he doesn't play the French, here's my question to you. Two-part question. How much odds do you give to Joker? Not Joker. Yes, that Joker. But how much odds do you give to Sinner? Remember, Sinner had like 8 match points against Alcaraz last year. Sinner should have won the French last year. How much probability do you give to Sinner? You'd have to take Sinner well over the rest of the field, right? And number 2, does it give Djokovic a chance if he's on the opposite side of the draw? Because then he only has to potentially beat one of them. What's your
I
thought?
guess. Yeah, I mean, my intro. Can you give me a little bit more, like, what before this injury? What would you have given? What would be the probability of somebody besides Alcaraz and Sinner winning?
Oh, I would have said at most 5%, 10%.
Oh, 10%. Yeah. I would have gone with that.
Yep. So I think, and again, it's kind of one of those things where, this is what we call the violation of the IIA property in marketing, which means I'm not going to redistribute the probability in proportion to the market shares of the other brands. I'm giving it all to the other dominant brand. I'm giving it all to Sinner.
Yeah, that makes sense.
All right, guys. Well, that's been 1 hour of Wharton Moneyball. I'd like to obviously thank our guest, Micah McCurdy, but on behalf of myself, Eric Bradlow, on behalf of my colleagues, Shane Jensen and Adi Wyner. Thanks to our producer, Dee Patel. Thanks to our other producer, Marissa Renna. Thanks to our associate producer and sound engineer, Dion Simpkins. On behalf of all of us at Wharton Moneyball, enjoy your statistics, enjoy your sports, and we'll see you next week here on the Wharton Podcast Network and Wharton Moneyball.